Okay, let's talk about inverse and inverse trig functions today. There's some important things to know. You should remember, hopefully, from Algebra 2, maybe even Algebra 1, especially pre-calc, what an inverse is. Alright, and this is the notation used for an inverse function. All you do is switch the x's and the y's. So this one, example 1, find the inverse function of these. Well, that would be just switching the x and y values of the points. Alright, so we have these coordinates here. That's a 2, okay. -1 and 7, 4. So for right now, I will also show you how to find it for a regular function. Remember, f of x we can just write as y. To solve for an inverse, you just switch the x and the y values, and then solve for y. Alright, so we add 8, and then we divide by 5. And we can write it as 1/5, or divide it all over 5. It doesn't matter, whatever you want to write it as. But instead of writing it as y, I'm just going to call it f inverse of x. So notice this would be the inverse. The opposite of multiplying by 5 and then subtracting 8 would be adding 8 and then dividing by 5. You're just kind of undoing what the function did. Alright, so there's a lot of material here that you can read. This is just kind of a review on inverse functions. And before we get too far, you have to remember not every function has an inverse function. Alright, so x squared would not have an inverse function because it does not pass the horizontal line test. And again, you can take the time to read this information. Alright, so as a graph, f and the inverse of f are just reflected about this line, y equals x. Because you switch the x and the y values. So graphically, it would look like this. There's some really important things about slopes of inverse functions. If you can't imagine what it is, then look on your paper. Inverse functions at the corresponding points have reciprocal slopes. It is so important that you realize this. So if we take a look here, this, I mean, it's almost 0, right? And this is almost vertical. This would be like a slope, I don't know, like 1/3 or something. This could be a slope of 3. So we're going to notice that, remember, in calculus, we're talking about slopes really often, how the graphs are changing. And so we have this huge relationship between the slopes of inverse functions. Alright, mathematically, this is how we state it, that the slope of the inverse of f is equal to the reciprocal. Alright, the slopes are reciprocal values. So in this example here, we're going to find f of 1. That would mean just plug 1 in. 1 cubed is 1 times 2 is 2, plus 1 is 3. F prime of 1. Well, first we might need to find f prime. So this part is A. Right, now we need to find f prime, which will be 6x squared. Oops, f prime of x equals 6x squared. And plus 1 is a constant, so we just have 6x squared. So now we need to find f prime of 1. Looks like that is 6. Alright, part C, f inverse of x. So we need to switch the x and the y values and solve for y. Or if you get really good, you can see it for a simple function like this. But I'll just start off by showing it to you. Alright, 2x cubed plus 1. So we switch the x and the y values. Okay, 2y cubed, and solve for y. First thing we should do is subtract 1. And we should also divide by 2 now, or just think about it as 1/2 of that. To show dividing by 2. And then our last step, is cube root. So we have the cube root of x minus 1 all over 2. Wow, that doesn't look like that at all. Okay, equals the inverse, f inverse of x. Alright, now we use that inverse function to find the inverse of 3. So I plug in 3 minus 1 over 2, cube root of that. Cube root of 1 is just 1. Alright, so the inverse function value evaluated at 3, oops, that should be f of to the negative 1, f inverse, equals 1. And then f inverse, the derivative of that, of 3. Well, one way I could do that would be by taking the derivative. So we have, let me see, I better just rewrite this function, f inverse of x. Rewriting that function, I'm going to write it to the 1/3 power. So I have 1/2 times x minus 1, x minus 1. Instead of writing cube root, I'm going to write to the 1/3 value, or 1/3 exponent, sorry. Now we take the derivative, so we're taking the derivative of the inverse function. So that would equal 1/3 times the original function there, to the 1/3 minus 1 exponent, which would be negative 2/3, times the derivative of the inside, which would simply be 1/2. Okay, so now I am trying to, I can simplify this also. I can multiply 1/2 and 1/3 and get 1/6, but I'm not going to do that this second. We are trying to evaluate the f inverse f prime, or the derivative of that at 3. So if you plug in a 3, 3 minus 1 is 2. Half of 2 is just 1. 1 to any power is just 1. So we have 1/6 times 1. That is one way to find the derivative of the inverse function evaluated at 3. The other way to do it is to recognize that the inverse, the derivative of the inverse is going to be the reciprocal of the derivative of the function at 3. Or at, the opposite value, not 3, sorry. When we plugged in 1, we got 3. So that means on our inverse function, we would have the point 3, 1. So to find the inverse, the derivative inverse value at 3, we need to take the reciprocal of the derivative of our original function at 1, which is just going to be 1/6. Okay, so then we have a few more problems that we can do. These aren't too bad. Use f prime of x and the continuity of f of x to determine if it's 1 to 1. Alright, so I guess we have to take the derivative of this function. So we get 5x to the 4th plus 2 for f prime of x. Well, in this case, can this function be negative at all? No, it can't. So we have the slope of f of x. F of x is always positive. I could have also said that the derivative is always positive. So that means that f of x is strictly or monotone increasing over its domain. Strictly increasing. Okay. increasing. So if it's always increasing, it's always going to pass the horizontal line test. So it is 1 to 1. So part B, right? Find f of 1, just plug in 1. And we get 1 to the 5th, that's just 1. Alright, there we go. Okay. 1 to the 5th is 1 plus 2 is 3 minus 1 is 2. So f of 1 equals 2. If we're going to find the derivative of the inverse evaluated at 2, we remember here that let me word it correctly, inverse functions at corresponding points have reciprocal slopes. So that means that if we're trying to find f inverse, the derivative of that, to evaluate it at 2, then it's just going to be the reciprocal of the slope of the original function at 1. So we need to find what f prime of 1 is, and if we plug that in, okay, 1 to the 4th is 5, and then times 5 is 5 plus 2 is 7. So it looks like this is going to be 1 over 7. Alright, so we have our answer right there, and we can maybe have time for one more example. It's just so much fun, we could do this all day if we really wanted to. Alright, so this here, the reason why they put this in the problem, this tells me that m and n are inverse functions. So I probably will have to use some of the properties of inverse functions that we have talked about. Alright, so we're trying to find n prime of negative 9. Alright, so we have m of 5 is negative 9. M prime of 5 is negative 8/11. If m and n are inverses, then we know that m prime of negative 9 is going to equal the reciprocal value of m prime of 5. And substituting the values that we have in, 1 over negative 8/11, just the reciprocal of that value, which would be a negative 11/8. So see, there's not a lot of work required if you know the material. You can't do this, you can't do any more of this problem if you don't understand the properties of inverses and their derivatives. I do want to just mention the next page. The trig functions that we've looked at are 1 to 1. None of them are 1 to 1. If we have sine of x, it's repeating. Cosine of x is repeating. It's always going to fail the horizontal line test. Okay, tangent is repeating. Cosecant, secant, none of those are 1 to 1. So we have to restrict the domain in order to have an inverse function. Alright, so the inverse of sine of x, we can only look at a certain portion. So maybe from here all the way to here. Or if we just restrict it to this part, it is 1 to 1. So this would be our inverse sine function. Alright, this portion, the red portion, would be our inverse tangent function. And this would be our inverse secant function. I guess I should save some of the derivatives of trig functions for our next video.